Okay, hello everyone. So here's the second video for this lesson, and we're going to take up the third exam, the final exam, and using the third exam to predict the final exam example. Now we want to know that the correlation is statistically significant. Okay, so they've given us a lot of information here that we found last time, right? That was our line of best fit from before, and that was our correlation coefficient. Okay, so let's go ahead and do full 8 steps to determine whether this correlation is statistically significant. Okay, so step 1 is what is the original claim? And so the original claim, let's go with the correlation is significant. Significant. And so what that means is that there is correlation. Meaning, we're going to say that rho is greater than or is not equal to 0. Because remember, rho equals 0 means there's no correlation. And so in this case, that would be step 2. Opposite of the original claim is rho equals 0. This means no correlation. All right, step 3. The null hypothesis, well, that's going to be rho equals 0. And the alternative hypothesis is going to be rho does not equal 0. Step 4 is right there, significance level. Step 5, we need to find our p-value. All right, let's go to Excel to do that. Well, no, not sorry, test statistic. All right, so let's go to Excel to do this. All right, so again, we've got our work from last time. Let's find our test statistic. So this is going to be our step 5. And so this is going to be a t-test. But in order to find t, I need r and I need n. That's really about it. So r is going to be this Corel function. So let me put in my data again. There's my x value. Now, does it matter which one I put in first? No. It doesn't matter. If I switch which one's first, which one's second, I'm going to get the same number. See, there it is. Okay, and then n, let's just go with count. That's all we're doing with n is counting. All right, there it is. Okay, so now I can do my standard error. My standard error is going to be the square root of parenthesis 1 minus r squared divided by n, my count, minus 2. Close the denominator, close the square root. That's my standard error. And so my t-value is going to equal r divided by my standard error. So 2.65 is my t-value. Now let's go on to step 6 and find the p-value. That is going to be, it's a two-tailed test, right? Well, let's do degrees of freedom before I do anything else. So this is going to be degrees of freedom. That's going to be n minus 2. Now, and I hope you're following along. All of this is, right, all of this is it's basically talked about right here. There's our test statistic that we used. Although it might be worth noting that we used a different form. But, you know, we've taken algebra, and so I think we might be able to see that this is equivalent. The form that I used was r over square root 1 minus r squared over n minus 2. Okay, these two things are equivalent because this is r over square root 1 minus r squared over square root n minus 2. How do you divide by a fraction? You multiply by the reciprocal. So n minus 2 over square root 1 minus r squared. And we get what they have. But I like this one because it really tells me what the standard error is, the thing on the bottom. Okay. All right, so I've got my degrees of freedom. Now I need my p-value. So this is going to be t dot dist dot 2t. It's a two-tailed test. I take that t-value, and I take that degrees of freedom, enter, and I get 0.26, which agrees with what they have in the book, 0.026. All right, let's go ahead and take a screenshot of this little bit right here. There you go. All right, so we get t equals 2.6576. Step 6, we get p equals 0.0262. And so here's my significance level. So we've got alpha. So step 7 is alpha. Step 7, we've got p is less than alpha, right? Alpha was again 0.05. And so this means I'm going to reject the null. So step 8 then is there is evidence to, okay, what's that evidence? The evidence is 0.0262, p equals that, and the null hypothesis contains the opposite of the original claim. The original claim here, which is positive, which is yes correlation, is in the alternative hypothesis, and so that means I'm going to use the term support. Okay, so there is evidence to support the claim that there is correlation. Right? To assume that there is, shh, Lily. So to assume that there is no correlation would not comport with my data. See, no correlation. Let me go back here to our Excel here. See, if there was no correlation, then I would expect this to look more like have these values be more of a rectangle, and have the variables not depend on each other at all. All right. Okay, very good. As far as using the critical method goes, we need to determine whether our R value is within that critical region. And how do we find the critical region? Well, we simply look it up. We've got 9 degrees of freedom. And so to find the bounds of my critical region, I go to my table in Excel. Okay, so I come to my table. I look up my degrees of freedom, and that gives me a cutoff of 0.602. And so that's 0.602 R 0. Let's see, that's negative there, positive here. And if my R is within that, then it's not significant. But if my R is outside of that, right, then it is significant. And so this one here, since my R is just a bit outside of it at 0.66, 0.66, where's my R? 31, that is out on this side. So it is outside of the interval, so is significant. Okay, and there we go. All right, so that's that example.